that would disarticulate and fall apart after the animals die and be scattered in this seaway and in these muds, or once in a while found in association with each other, but not in 3 dimensions as you see them exhibited. Go back once more. All of these pictures you see anywhere of Dunkleosteus in museums of fossils don't have anything really about the back end of these things. And that's because nobody knows much about the back end of Dunkleosteus. These big bony plates are found in these concretions, and the rest of the skeleton is presumably cartilaginous. Is it preserving? Is it not preserving? Well, it's not being collected one way or the other. So we don't find, usually, any cartilaginous elements associated with these big arthrodires from the Cleveland Shale. So how do we reconstruct them? How do we know what they might have looked like? And that's where we'll go to the next slide. We can go to the Middle Devonian close relative called Dunkleosteus. This is from the Middle Devonian Old Red Sandstone of Scotland. And here are those same dermal plates, the cephalic and thoracic shields. And then in these things, we do get the cartilaginous skeleton often preserved in the similar anoxic bottom. There may be some calcification to the cartilage that gives it more preservability, but you can see the skeleton here. These are the spines in the top of the vertebral column, and those at the bottom, the humeral arches. The body of the vertebrae, the centra, they are completely cartilaginous, not preserved at all, and then a dorsal fin here. So it's Dunkleosteus that's been used as a model for reconstructing Dunkleosteus in the flesh. Like this. And somebody was asking how big it is. And it's pretty big. Of course, they were small when they got started. There are a lot of small examples. But that big Cleveland specimen that's so famous is an animal about this size. So what's that? 5 meters? Something like that.
20 feet.
Yeah, 20 feet long. Something like that. So a big, fearsome animal. I like to call these, staple removers. Okay. A reconstruction again of what this thing may have been looking like as it was swimming around. Next, we've got a couple of reconstructions. Here's a more modern one, maybe, chasing those sharks, those cladoselachians that are also known commonly. Dunkleosteus and Cladoselacia are the 2 most common fossils in the Cleveland Shale. Not that you find them every day by any means, but relative to the other things that are in there, they are the most common. So here we have a reconstruction of Dunkleosteus preying on sharks, clearly with those big tusks. Remember, they're not true teeth, but those big bony tusks. This is a predatory animal. And eating the sharks is probably a good guess. However, we know they ate each other because in our museum and some others, there are Dunkleosteus plates preserved with big cut marks, big bite marks in them. We also find coprolites, fossil feces, fossil droppings, that have macerated arthrodire bone inside them. So they're cannibalizing one another too. This is not an old idea, eating the sharks. Not a new idea. There are older reconstructions. This is probably from the 50s, this one. Chase after sharks next. Just a picture of a few additional plates, the kinds of things that you usually find. You don't often find the whole animal. You usually just find the individual plates. This is not the Cleveland Shale, however. This is from the equivalent down in Kentucky near Clay City. We've worked with bone bed that's produced lots of individual plates of Dunkleosteus-like animals. Big arthrodires, maybe not Dunkleosteus exactly. But again, the lower jaw, this is the back of the upper jaw, and some other bones in the skull. Right, so the question, how did that big skeleton get found and reconstructed the way we see it today? These are the plates of that original skeleton when it was first worked out of the rock. I'm sorry, not that original skeleton, but the big famous one that you see in all the museums. So here's the head shield, the thing that I showed you in that one of those early slides of fossils that we collected. there are various plates. This is called the suborbital. Here are the infranathals, right? So this is the whole thing sort of exploded out. What happened in this case is a large concretion, or perhaps a series of concretions were found that had the bones associated with them. The animal had disarticulated and crushed down upon itself as it started to decay and as sediment built up on top of it. And this was worked out probably 1930s and 40s with hammer and chisel, just cutting it out of the rock. And what happened is all these pieces got broken up, and then they glued them back together and plastered them, and they then attempted to reinflate it and reconstruct it. Some of these are not the actual bones. These are plaster casts, so these ones here, because they weren't present, they weren't found, they had washed away before the animal was buried or who knows what. So it is a good part of the skeleton, head and shoulder skeleton. It's not complete, but it was in these concretions. And that was a lot of work, particularly in those days, chipping the thing out of the rock. Next slide. So here's an example of it going together in the early days. This is Peter Bungart, a fellow who found it. And here you can see, I think, these are plaster bones, bits of bone. Here's what the real bone looks like. And you can see all those breaks and bits of plaster in between the breaks. They're chipping them out of the rock, and the bones are breaking, and they're gluing them back together. And they did a remarkable job, really. I mean, it is an iconic fossil. It's a great exhibit piece, and we know a lot about Dunkleosteus as a result. Having said that, if you take the bones out of the rock like that, you lose some information, too, about how they're preserved and how they're associated. Next slide. Here's a new specimen of Dunkleosteus. And hard to make out, maybe, but here's the whole thing, probably similar to the way that other specimen collected in 1928 was found, crushed flat with all the bones together, more or less, and then they would have worked them out of the rock. What we've done in this case is try to remove the matrix and leave the bones in place. It's not as great an exhibit specimen, but from a research perspective, it gives us much more information than was had from that classic specimen. And this is not to point fingers, it's just that our techniques and our ability to prepare fossils have really advanced since 1928. So we're able to use air scribes and air abrasive machines that weren't available to the preparers in those days. So anyhow, this is a Dunkleosteus specimen. This is a ½ meter, this stick here. Next, Libby, and just a schematic to kind of show you what we were looking at there. Here are the lower jaws. We're looking at from the throat, the underside of this animal. It's crushed, it's on its back, and we're looking at the underside. So here are the lower jaws in articulation. These are the two upper tusks. Here's the eye, or orbit, the suborbital bone, or the cheek area. And then there are various plates in the belly. These big plates are called median dorsals. They're way in the back. They've sort of slipped forward as this thing, or maybe the thing slipped backwards as it was decomposing, falling in on itself. Next slide. So those median dorsals are here, right? Here's the suborbital cheek plate, et cetera, and then the upper tusks and the lower jaws. Next slide. Okay, leaving the fossil preserved like this does give us the chance to learn something new about this animal. The last time that that Dunkleosteus Deinictes at the time was described was Anatole Heinz. When was that? Dale, do you remember? I think it's in the 40s sometime, when the last good description of Dunkleosteus was made. What he would not have been able to see in those early specimens are things like this. Well, let's move on to the next slide. Let's see. That's in the throat area. These are the bones. Well, go back one, just so you can see where that. So here's the lower jaws. Okay. Here's the upper tusks here, and then we're looking right underneath the jaw, in the throat area. In the next slide. These are the branchial arches. It's calcified cartilage, branchial plates that support the gills. So this tells us something about the gill structure of this animal. It tells us allows us to estimate the size of the gill chamber as well. Next slide. I'm just showing you a few examples. Here is an amorphous sort of brown blob. This is the lower jaw. So here are those, let me see, here are those gill structures again. So the front of the animal's up this way. Here's the jaws. This brown blob is apparently soft tissue, some of the skin of this animal. So that's the kind of thing that we can learn when we use the modern techniques and try not to disassemble these fossils. After all, we can always use the cast of the one they've already done that to for exhibit. I should say that these are all been collected under permit up in the Cleveland area. One just can't go out and collect fossils there unless you can find a place that's private land and get permission or something like that. Most of the classic exposures are in the Metro Park system up in Cleveland and require a permit.